This is your first video for Unit 2, which is our astronomy unit, and we'll be concentrating on the Sun, Earth, and the Moon. So before we can talk about the Sun, the Earth, and the Moon in our own solar system, we need to look at the universe as a whole. So starting from the very beginning, about 15 billion years ago, there was a tremendous explosion that started the expansion of the universe, and this is the explosion that's known as the Big Bang. So at this time, all matter and energy in space was contained at one point. And it's probably not like you are picturing. You're probably picturing a bomb going off and an explosion. But it was an event that occurred that caused all the particles to rush away from each other and expanding the universe. So the origin of the Big Bang Theory can be credited back to Edwin Hubble and some of his discoveries with his telescope. So Hubble's law says that galaxies are retreating from the Milky Way at a speed that is proportional to their distance. The Milky Way is our galaxy, and if we measure our distance to other galaxies, we see that they are moving further away. And those that are farther away are moving faster. We know this by studying redshifts of distant galaxies. And on the next couple of slides, we'll talk about what redshifts are. But for right now, everything that we've observed does indicate that our universe is expanding. So this supports that idea of the Big Bang in that if the universe is expanding, then it had to come from some central point. All right, so redshift has to do with the colors of the spectrum. Red light has a longer wavelength than blue light. So when we talk about Doppler shift, you've probably noticed this when you heard a fire truck or a police car. As it passes you and moves away, the sound changes. And the reason is, if you look at our diagram down here, when it's moving towards you, the sound waves are closer together, so we have a shorter wavelength. When it's past you and moving away, the sound waves are further apart, a lower frequency, so you have a lower pitch sound, and a longer wavelength. The same thing happens with light. Something that's moving away from you is going to have a shorter wavelength, so if we look at its spectrum, it would be giving off a red light. Something that's moving towards you has compressed, so it has a shorter wavelength and is closer to the blue end of the spectrum. So what we've studied with stars and galaxies is that they are in fact giving off a red shift, which means they are moving away from us, and we know this because of that longer wavelength. All right, so to visualize, think about a loaf of raisin bran. You've got your dough, you set it out to rise, and as it doubles in size, the distance between all the raisins increases. So here we start with our dough before rising, and you can see that the objects that are located farther apart, like these two raisins, move away from each other much quicker than objects that are closer together, like these two raisins. All right, so the Big Bang Theory, as we said, says that at one time the entire universe was a dense, hot, supermassive ball, and that about 13.7 billion years ago, a violent explosion occurred, which hurled all that material in all directions. All right, so if we look at what's happened since the Big Bang, so our Big Bang starts here, and this is what happens in the first few seconds all the way to the present time, which is billions of years later. And you can see how all of that matter and energy has expanded. All right, so our supporting evidence, number one, is that the redshift of the galaxies supports the Big Bang and that the universe is expanding. The second type of supporting evidence is what is called cosmic background radiation. Scientists have discovered energy that's being given off, and when we look at that energy, they've determined that it was produced during the Big Bang. So that's the second piece of evidence that supports that yes, there was a Big Bang, and yes, we are expanding. All right, so what next? Will we continue expanding forever, or will something else happen? So there's another theory called the Big Crunch. So two possibilities for the future of our universe. Number one, that it will expand forever. Eventually the stars will die out. There will be no energy left. The second theory is that the outward expansion will stop and gravitational contraction will follow. So everything that expanded is going to contract once again towards that center where the Big Bang occurred. Of those two possible paths, most scientists believe that the universe will continue expanding with no endpoint. But you can see from the diagram here, it's called a closed universe if we have the expansion followed by the contraction or the big crunch, which means that could be followed by another Big Bang, and it's just a constant cycle that we follow. Or the open universe theory that will continue expanding forever. Okay, and that's it for day 1.